Has this ever happened to you?
I can't move this submarine!
Ah! Well, by the end of this video, you'll be saying,
wow, I can move this submarine!
Hey there, I'm Cyber Chroma, and today we're making a submarine! We'll take this motionless hunk of metal, and over the next 20 minutes, we'll get it to move forwards and backwards, spin left and right, rise up, sink down, and even correct its rotation when it bonks into stuff. As a bonus, we'll also program some animations, like these turbines that spin depending on how you move, having the fins turn as you move vertically, and having this turning drill in the front. And don't worry, the visuals are just to make the video look cool. No matter your skill with Unity, you can follow along with some colored cubes and you'll do just fine. And to show how much work I've put into this tutorial, here's how long the different parts of the video took to make. So I hope you enjoy it. Now without further ado, let's get started. To start things off, there are a number of topics that we will be going over, so feel free to use this table of contents to find what you're looking for, or watch the whole thing, which I'd appreciate. Now, the first item on our agenda will be going over what we already have in our scene. So in my project here, while it might look like there's a lot of stuff going on, don't be intimidated. This is all basically just for all the art stuff going on. Now, this project was made using the HD render pipeline, but thankfully that won't affect our code. To make things crystal clear, I've separated everything in the project view into two folders. Art stuff, that contains all the models and everything to do with making the scene look nice, and tutorial, which contains the submarine prefab so it can be easily copied to other levels, the scene that we're currently working in, and the place that we'll be writing our code. Now, you'll notice that I do have one script here already, and this is simply just to make these pipes on the submarine move up and down, just for some artistic flair. And unless you're copying my exact model, this probably won't help you too much with making a submarine, but in case you're interested, here's the code for it. Now, let's look at the hierarchy. We have the camera pointed to look at our submarine from behind, but otherwise has no changes. Then we have the submarine itself, which at the moment is just a model with some colliders and a spotlight that shines into the distance. Then we have this undersea environment. And lastly, all the lighting and post-processing that makes the scene look like it's underwater. That's it for the setup. Now we'll start controlling our submarine. We have many different ways that we want to get our sub to move, and I'd say that moving forwards and backwards is probably the most important one. So let's start with that. With whatever you want to get to move like a submarine, be it a box, capsule, whatever, the first thing that we'll want to do is add a rigid body component. We can do this by selecting our sub-object, going to Add Component, and typing Rigid Body. This will allow physics to act on our object, so in code we can apply pushing forces to it and have it behave in a realistic manner. By default, the rigid body will work, but there's some settings that we'll want to change. In order, we'll want to change mass to 5, drag to 1, and angular drag also to 1. These mass and drag values are arbitrary, and you can modify them if you'd like. I just found that these values work well with the code that we're about to write. In addition, you'll also want to set use gravity to false, unless you're planning on piloting a plane without wings instead of a submarine. Now, these physics are all fine and dandy, but if we want to actually do some pushing, we're going to have to write some code. So finally, let's get to that. In the scripts folder, let's make a script to control our submarine and call it subcontroller. Then we can open it up. You'll notice that, by default, there are two functions here, start and update. In simple terms, start runs when we first start the game, and update runs constantly throughout the game. First, let's go ahead and grab that rigid body component so we can use it. At the top, type private rigid body RB. In start, type RB equals get component rigid body. When we run our game, this will grab the rigid body and store it in RB, so now we can use it to move our sub. Since we are going to be using physics, we'll want to change the name of update to fixed update. The short explanation is that fixed update is a lot more consistent in how it runs compared to update, so it's always good to put physics code in fixed update. And now, it's about time we talk about how we're going to be actually moving our submarine. Rather than just getting our submarine to move forwards and backwards like a car, for example, we are going to set up a current speed for the sub, and then be able to raise or lower that speed depending on the player pressing the W and S keys, respectively. So then, when they let go of the button, the sub will continue moving with that speed. So, let's go and set up that current speed. At the top again, let's make a private float that we'll call curSpeed. Now, pretend the player set the speed to 10, which we can do by going in fixed update and typing curSpeed equals 10. Now, we can use this value along with our rigid body to move the sub with rb.addForce transform.forward times curSpeed. As the name implies, add force will apply a force in a given direction, in this case, the forward-facing direction of our sub, multiplied by our speed. Let's go ahead and run this in Unity. We can do this by simply selecting our sub and dragging the script into the empty area of the inspector. We can run our game, and ta-da! Our sub moves. Now, let's control it with player input. To test if the player hits the W key, we can type if input.getKey keycode.w. If they hit the W key, everything in these brackets will run. So now we want to increase the current speed. But by how much? Let's make a new variable, this time a public float, so we can edit it in the inspector. Let's call it speed change amount. This is so we can now type cur speed plus equals speed change amount. This will add speed change amount to the current speed. To go in reverse, we can first copy and paste this code, and then change the W to an S, so we are testing for the S key, add an else at the beginning, so we can't do both at the same time, and change the plus to a minus, so that we can decrease the speed, eventually into the negatives, to move backwards.
Back in the inspector, if we set the speed change amount to 0.2, now the sub moves when we press the buttons.
Now we'll want to give it a few tweaks, such as setting some max values so, we don't speed up forever. Let's make two new variables, max forward speed and max backward speed. Then, right before we actually apply the force with cur speed, we want to make sure that it stays between these values by typing cur speed equals mathf.clamp cur speed, comma, negative, max backward speed, comma, max forward speed. Clamp will make sure that number stays between a minimum value, our backward speed, and a maximum value, our forward speed. We'll set these to 20 for the forward speed and 15 to the backward speed. As well, let's set a small minimum speed, so that when our current speed gets really low, we can just set it to 0. That way, it'll be a lot easier if we want to get our sub to just stop moving entirely. Let's make a new variable called min speed. Then, we want to test whether our current speed is less than the minimum speed, so we'll add to our if statement with else if mathf.absolute cur speed is less than or equal to min speed. This will also make sure to get the absolute value of our speed, which is always positive. If the speed is too low, then we want to set current speed to 0. We will set this to 0.5. Now all of our forwards and backwards movement is done, but right now it just zooms into the distance because the camera isn't set up to follow it. So let's fix that. We can do this by setting up a camera pivot that follows the submarine smoothly. Create a new game object and rename it to camera pivot. Set this object's position to match the player's position. Then make the camera a child object of the pivot. Now, if we move or rotate the pivot, the camera moves with it and rotates in a circle around it. Now we'll make a script to get the camera pivot to match the sub's position and rotation with just a little bit of smoothing. Let's make a new script, camera follow. Inside, let's make 3 variables right away that will all be public. First is target. This will be the object that the camera follows. The next 2 are move smoothing and rotation smoothing. As the names might suggest, these will be how smoothly the camera follows the sub and how smoothly it rotates to match the sub's rotation. You can also think of these variables kind of like speeds, where the higher they are, the faster it follows. And now in start, let's make sure that the camera pivot actually starts in the correct place, which is on the player. We can do this by directly setting the position with transform.position equals target.position, and likewise the rotation with transform.rotation equals target.rotation. In update, to get this smooth following to happen, we're going to use a function called lerp, or linear interpolation. We can type transform.position equals vector3.lerp, transform.position, target.position, move smoothing. Then, for the rotation, we can use a similar function, slerp, or spherical linear interpolation, and we can type transform.position equals quaternion.slerp, transform.rotation, target.rotation, rotation smoothing. These words, vector and quaternion, aren't coming out of nowhere. A vector is what the position is stored as, and a quaternion is what stores the rotation. Lastly, we'll once again want to change the name of update to fixed update. This time, it's because we want to make sure that the player and camera movement are in the same type of update function, otherwise this can cause some very noticeable jitter.
Giving the camera follow script to the camera pivot parent, supplying the player as the target, and setting move smoothing to 0.04 and rotation smoothing to 0.02, now the camera is working just as we want.
With the camera working, let's get back to our sub, and next we'll get it to spin left and right. Back in our sub controller script, let's first make a variable for the turn speed. The turning will actually be a lot simpler, as we'll simply turn right when we hit the D key and left when we hit the A key. So first, let's get those inputs, in the same way as last time. If we press D, we want to use our rigid body again to apply a turning force to turn the sub. This is called torque, so we can type rb.addTorque transform.up times turn speed. Transform.up will get the up direction of the sub, so even if it spins around, it will turn based on its up direction. Next, we can copy this code to turn in the other direction when we press A. This is all we need for the turning, and we can set the turn speed to 2. See? Simple.
Our next step is to have the sub rise and lower by having it move up and down. Thankfully, this process is actually very similar to how we turned the sub. You know the drill by now. Let's start by making a variable for the rise speed. Then, let's get the buttons we want to use. In my case, I'm using left shift to rise and left control to sync, but you can make the buttons whatever you want. Like moving forwards and backwards, since we want to push our sub again, we will use add force and push the sub with transform.up based on our rise speed. Then, for syncing, we can simply do the same thing, but with a negative rise speed. Setting this to 10, we can slowly move up and down. We can now move in all the directions that we want to, so now let's take care of that stabilization turning as well. First, let's make a variable called Stabilization Smoothing. Then, to actually stabilize the sub, all we want to do is take whatever the rotation it has right now and slowly turn it to have 0 in the X and Z part of its rotation, but leave the Y part just as it was before. Surprisingly, this can actually be done in only one line of code, but it is a long one. Brace yourselves. rb.moveRotation quaternion.slurp rb.rotation, quaternion.euler new vector 3 0, rb.rotation.euler-angles.y, 0, stabilization smoothing. And tons of brackets. Whew! We can set the stabilization smoothing to 0.05, and presto! The sub will now always turn to face upright. Lastly, I'd like to do a bit of reorganizing by splitting up all of these different parts into their own functions. Under fixed update, let's declare the functions move, turn, rise, and stabilize. Then we can copy all of our separate sections of code into these functions and call them one by one. This is just to make our code just a little bit more readable. And with that, we now have a functional submarine. Now, to make our sub look even better, let's program those animations. Yeah, that's right, we're going to be programming them manually. But don't worry, they aren't too complicated. The main reason I want to do this is for the turbine, to get it to spin differently depending on how we move. So, let's start there. First, let's make a new script called Sub-Animations. I'm only doing this to keep the movement and animations mostly separate for the sake of the tutorial. Although, we will want to add a few things to our subcontroller just to make things a little bit more convenient for us. So to spin our turbine, we will want to call a function here to make it spin at different speeds that vary with how our sub moves. As this is just for decorative purposes, we're going to want to turn the turbine directly through its rotation rather than using physics. We can delete the start and update functions as we won't be needing them. Instead, we'll make a new function called spin and set to public that will take a direction as input. In a moment, we will call this function from our move code. So let's assume for a moment that we have these directions as 1 if we're moving forwards, -1 if we're moving backwards, and 0 if we're stopped. And rather than just immediately turning at these speeds, let's keep track of the speed that we were turning at last frame to slowly move to turning at that speed. At the top, let's make variables for all of these things. As well, let's make a public variable that's a reference to the turbine object that we want to spin. For me, this will be the turbine that I created, but you can use whatever you have. To calculate how much we should turn this frame, we will use mathf.moveTowards, a function similar to the lerp function we used earlier. Storing this rotation in a new variable, we will type float curturn equals mathf.moveTowards last turbine turn, turbine turn speed times dir, turbine smoothing times time.delta time. Since we aren't using physics, we will want to multiply our smoothing value by time.delta time so that this will happen consistently regardless of the frame rate of your game. Using this curturn value, we will turn the turbine with turbine.rotate new vector 3 0, 0, curturn. Then we will store the curturn value in the last turbine turn so that next frame it will be the last value. This will get the turbine to spin how we want it to, but now we have to actually call the function with the proper directions. Back in the subcontroller, we first need to get a reference to the sub-animation script so we can call the function on it. At the top, type private sub-animations with a capital S, subanimations with a lowercase s. And in start, subanimations with a lowercase s equals get component subanimations with a capital S. Keep note of the capitals. Notice how this is identical to how we got the rigid body, and the lowercase names at the end, RB and subanimations with a lowercase s, are completely arbitrary and we can name them whatever we want. In the move function, we can now call the spin function. When we press W, we want it to spin full speed forwards. So in this if statement, we can add subanimations.spin1. When we press S, we want it to spin full speed backwards, so we can do the same thing, but with a -1. Then, if we aren't pressing any buttons, we want to slow the speed to 0. I'm now going to add one more behavior of this turbine. If we aren't pressing W or S, but we are still moving, I want to get the turbine to keep spinning in that direction, but let's say at half the speed. So let's test that the current speed is not 0, and then call the spin function again. For the direction, to get the direction that we're currently heading in, we'll use the absolute value of our current speed, and type cur_speed divided by mathf.absolute cur_speed divided by 2. If we attach the animation script to our sub, give it the turbine object, and set the spin speed to 20 and smoothing to 25, now we have a spinning turbine. I bet you could also move this to the front and use it as a propeller for a plane. Next we have the fins, which will be very similar. So similar, in fact, that we will start by copying our spin function and renaming it to fin turn. We want our fins to turn downwards a bit when we rise and turn upwards a bit when we sink. Let's make a public reference for our fins object, like we did with the turbine, and let's make variables for the turn amount, the smoothing in the turning, and the last fin turn amount. Just like before, we will have the turning happen smoothly instead of snapping. In our fin turn function, we will use cur turn to set where we want to turn to. Last time with the turbine, we used cur turn as a turn velocity, but this time we more so want to use it as a rotation to turn to instead. So we will change what we have to float cur turn equals mathf.lerp last fin turn, comma fin turn amount times dir, comma fin smoothing times time.delta time. Then, instead of using transform.rotate, we will set the rotation more directly with fins.localRotation equals quaternion.euler new vector 3 -90 plus cur turn, comma 0, comma 0. In my case, -90 is the default x rotation of my fins, with the other parts being 0, so you may have to set this to something different for your case. Then we can change last turbine turn to last fin turn, and this is all we need for the fin turn function, so let's go back to the subcontroller to call it. In our rise function, we can simply call it with 3 different directions depending on the button we pressed, -1, 1, and 0. Now if we get the fins reference and set the fin turn amount to 15 and the smoothing to 1, the fins move just how we want. For a good rule of threes, let's get that drill to turn as well, based on our left-right turning. Luckily, this part is even closer to what we just did, so we can get it done a lot quicker. Make a reference to the drill. Make variables for the drill turn amount, smoothing, and last turn amount. Copy the fin turn function and name it drill turn. Change the variable names to the drill versions. Go back to the turn function in subcontroller. Call the drill turn function 1 for right, -1 for left, and 0 for neutral. Set up the variables in Unity, with 30 for the turn, 4 for the smoothing. And huzzah! The drill now turns! I hope that shows you just how easy it is to make simple animations that respond to how you move. Especially for a slow-moving sub, this already makes it feel more alive. And there we go! We've gotten this sub to move! We made the camera follow it! We made it turn! We made it rise! We stabilized it! We animated the turbine, fins, and drill! And with all of that, our underwater submarine is finally complete! With this done, I present to you a challenge. I want you to use this to make some kind of submarine game. You just made the movement, now use it. You could have to collect treasure, fly through hoops, dodge sharks, who knows? Whatever you make, just make it creative. As well, you can download all the files from all my tutorials in the description. Feel free to use them however you'd like. If you make something cool with it, I'd love to hear about it. Now how about that? You made it to the end of the video. Honestly, thank you. I appreciate you taking the time to watch something that I put so much work into. And if it helped you out or you learned something new, then that's just a bonus. As for myself, I've learned so much from making this tutorial. From getting better at 3D art to make the submarine and the undersea environment, to getting better at video editing and just talking in front of a camera. Now this is something that I want to continue doing as I cover a multitude of different topics. So if you have ideas for anything that you want to see, tutorials or otherwise, then let me know. And be sure to subscribe if you want to see more of the stuff I make. Speaking of which, I'm now continuing to work on my next big game in Abstract Adventure, so look forward to many progress videos on that. Anywho, thank you all so much for watching, and as always, I'll see you around.